All right, so you guys need to be on this first slide for a second. I want you to understand something. You need to write this down, all right? When we're solving inequalities, we can treat it just like it's an equation. You can look at it like it's an equation. Excuse me, what's that? You're fine. But the thing that's different that you absolutely have to pay such close attention to is right here. If you multiply or divide by a negative, if you multiply or divide by a negative, taking the reciprocal is the same as dividing. If you multiply or divide by a negative, you have to reverse the direction of the inequality sign. That means you have to flip it. You guys have learned that before. It's just a matter, you have to remember to do that. If you don't do that, you will not get the correct answer. You have to reverse. You have to flip the negative sign if you multiply or divide by a negative number. So let's just go through a bunch of examples, talk about how to solve, how to check, and you guys are going to have to graph. So make sure you're paying attention to everything. We're going to practice this a whole bunch tomorrow, over the weekend, then we're going to go over it on Monday and take our little test on it Tuesday. But if you have this first inequality, first of all, we need to know what the signs are, how to read them. So let's do a little answer key up here, or a little legend. Write this down. Everybody write this down. What do those two things say? Less than and less than or equal to. Which one is the and or equal to? The one on the bottom, the one with the line underneath it. Okay, what does this one say? Greater than or equal to. What you guys need to understand, you have to be able to read these. You cannot tell me, oh, I'm not good at reading these. Which way does the mouth open? No, we're in high school now, right? It's less than or equal to, greater than or equal to. If you do not have a line underneath, it means it does not include that value. Doesn't include. And you have an open dot on your graph. We'll talk about that in a second. If you have an or equal to underneath, it means it does include that value. What kind of a dot do you have? A closed one, a filled in one. Good. Very, very important, because when you guys are solving these, I'm going to look for your answer, which would be your point, which you would be shading left or right on your graph. I'm going to look to see if you shaded in the correct direction. I'm going to look if you have an open and closed dot where you should. All those things go into the correct answer. So it's just like solving an equation, but then we also have some very important pieces of information that have to be on there, because you're not getting x equals a number. You're getting a range of values. You're getting stuff, it's in between here and here. Or it's anything bigger than this, or anything smaller than this. So if I look at this first inequality, what does that say? 3x is less than 9x plus 4. All right, the same thing as we would do to solve an equation. You want to get x's on one side, numbers on the other. I would try to always move your x's to the left-hand side. How would I do that? What would I do to get my x's to move to the left-hand side of the inequality sign? Okay, subtract 9x. Good. I'm going to subtract 9x from both sides. 3x minus 9x gives me negative 6x is less than 4. Now what do? Divide both sides by a negative 6. If I multiply or divide by a negative number, what do I have to do to my sign? I have to flip it. If you guys don't do that, your answer is incorrect. Can we simplify for a negative 6? Yes, this becomes negative 2/3. That is part of your answer. The rest of your answer that I'm looking for is the graph of the solution. All I need to see on your number line is 0 for a reference point. And where would negative 2/3 be in comparison to 0?
Between 1 and 0.
Okay, negative 2/3. Is it to the left-hand side of 0 or to the right-hand side? Okay, the left. You guys don't have to write out 1 through 10 or anything like that. I just need to see 0, and then I need you to understand that it's less than 0. It's on the left-hand side. So now let's think about what our shading should look like. Is this an open dot or a closed dot?
Open.
Why is it open? There's no underneath or equal to. So it's going to be an open dot. And when my variable is on the left-hand side, you can just kind of go like this. And that'll give you the direction that you shade. Which way should we color?
Left. Right. To the right.
Which way is the arrow pointing?
Right.
To the right. So everything over here. And you should definitely take a second to check your answer. I would always check 0. Since I colored, right? Do you see how 0 is included in my solution? When I plug 0 into my original inequality, should it work?
Yes.
Yes. So let's plug in 0 up here. Just mental math. What's 3 times 0? 0. What's 9 times 0? Plus 4. Is 0 less than 4?
Yes.
Yes. So I am correct here. Questions?
Is there a difference between shading it in and not shading it in? Or it doesn't matter?
I don't understand what you mean. Yeah, you can use pen or color pencils. That's fine. All right, look at the next one. How is this one a little different? There's 2 sides. X is where? In the middle. Our X is in the middle. When you have an inequality like this, you have to treat each side separately. You have to do what you do to the right-hand side, you have to do to the left-hand side. So we are trying to isolate our X. We're trying to get X all by itself. So how would I do that? I would add 2. Now when I add 2, guys, I'm going to add 2 to the right-hand side and the left-hand side. So add 2, and add 2. So 4 plus 2 is 6, less than or equal to 3x, less than, what's 13 plus 2? 15, good. Now I want to get x all by itself, so I divide by 3. I divide everything by 3. So I have 6 divided by 3 is 2, is less than or equal to x, which is less than, was 15 divided by 3? 5, good.
Don't you flip the sign?
No.
That's only when it's
Only flip the sign if you divide or multiply by a negative number. Good question. So now if I'm going to graph this solution, guys, draw your number line. I have to have 0 on it as a reference. I have the 2 points 2 and 5. What kind of a dot do I have it to?
closed.
Why is it closed?
It has an equal.
Because it has the equal sign underneath. Good. What kind of a dot do I have at 5?
Open.
Open. Perfect. And where do you think I color?
Between.
In the middle. Very good. How do you know that you're supposed to color in the middle?
Because the X is kind of in the middle.
Because the X is in the middle. Good. If this was an OR problem, and we'll talk about some OR problems, this or that, you would shade on the outsides.
So when the X is in the middle, it's going to be like that. They're going to be shaded in.
Or sometimes you'll have an OR problem, and we'll talk more about that tomorrow. I just want to kind of get the basics down here, but we'll have OR problems where it's one way or the other. There you go. All right, let's go through some problems together. Let's go through some practice problems. First of all, I was doing these last night. This should have an X on it. Make this negative. Make it negative 2x. Okay, I'm trying to get x all by itself. So what do I do? Divide by negative 2. Guys, when you multiply or divide by a negative number, what do you do to the inequality sign? You flip it. Very good. So 8 divided by negative 2 is? Negative 4. Can anybody read that inequality to me? Okay, x is less than or equal to negative 4. So 0 on here, and I have negative 4 is going to be to the left of 0. Now, which way am I going to color, and what kind of a dot do I have at negative 4? Closed dot. I'm going to color to the left. Check 0. Should 0 work? Yes or no?
Yes.
Should 0 work? The way that I shaded, should 0 work? No, so check 0. Plug it in here. What's negative 2 times 0?
0.
Is 0 greater than 8? No, so good. Your solution is correct because you did not include 0. It's always good to check 0. If you colored over 0, then 0 should make your inequality true. If you did not color on 0, then it should make your inequality false. But 0 is an easy number to use. Yes, ma'am. All right, look, we're going to try and isolate x. We want x all by itself. So what do we have to do? Subtract 11. So 3x is less than negative 6, right? And then what?
Divide by 3.
divide by 3. So x is what? What negative 2? Less than. Say with confidence. Do I flip the sign? No. Did I multiply or divide by a negative number? No. Is negative 6 negative? Yes. But I didn't do anything with negative 6. It was just sitting there. We divided both sides by positive 3. So when I go to graph this, I have 0 on my number line, and I have negative 2 to the left of 0. What kind of a dot do I have at negative 2? It's open because it does not include. And which way am I going to color? To the left.
Wait, that's matters?
Uh-huh.
So if you divide by a negative, it's like a switch or something.
Correct. If you multiply or divide by a negative. Now look, 0. Did I shade in 0? No. 0 is not part of my solution set. So if I plug 0 into the original inequality, should it make my inequality true? No. I don't have it included. I do not visually have it included. So when I plug it in, it should not make my inequality true. What is 3 times 0? 0. So if I plug in 0 here, this becomes 11 is less than 5. Is that true? No. So I am correct by not including 0. That means I colored the correct way. How's this one a little different? It's on the opposite side. Do you see how your variable is on the opposite side? If you don't like that, the first thing you can do is if you flip the sides that things are on, what do you do to the inequality sign? You'd flip it. You could rewrite this as 5 minus 2x is greater than 1. I always like to have my variables on the left-hand side with inequality, so I would do that first. I would flip it. If you flip the sides of your things, if you move the left side to the right and the right to the left to begin with, you have to flip the sign. But now if we go about solving, how do I get x all by itself? I'm going to subtract 5. Good. So I have negative 2x is greater than negative 4. Now what? Divide by negative 2. What did I divide by? Which means I do what? Flip the sign. Good. Negative 4 divided by negative 2 is 2. So now when we graph it, we have 0. We have 2. What kind of a dot do we have at 2? Open. And which way am I going to color?
Right.
Where is my sign pointing? It says x is less than 2. Where are all the x values less than 2? They're this way. This way is less than 2. Question.
If you didn't flip it, because I flipped it, I didn't flip it. How you?
If I plug in 0 to my original inequality, should it work?
No.
Yes.
Where did I color? Is 0 shaded?
Yeah.
So it should work. So when I plug in 0 up here, what is 2 times 0? Is this inequality true? 1 is less than 5.
Yes.
Then this is correct. So if you didn't flip it, 1 is less than 5 minus 2x. Okay, you guys didn't flip, right? So you subtracted 5 from both sides. You got negative 4 is less than negative 2x, right? Divided both sides by. And you got 2 is less than x, right?
No, I didn't. No, I flipped it.
You flipped it,
divided
yeah.
So you got 2 is greater than x.
Yeah.
Okay. Okay, so you didn't flip. So here's 0 and here's 2, right? So you got 2 is greater than x.
Yeah.
So you shaded to the right because it says 2 is greater than x, right? You can't follow that rule of which way the arrow is pointing, because if you were to read that 2 is greater than x, it's saying that 2 is bigger than all of the x values. So where is 2 bigger than all of the x values? All of these. Over here, 2 is, you see what I'm saying? Like if you read it backwards, x is what then 2?
Less than.
Yeah. X is less than 2.
That's really confusing.
I know. Whenever you have it, you can leave it like that. Like, you totally can leave it like that. But when you get to this point, you have to read your inequality backwards. 2 is greater than x. They're saying that 2 is bigger than all the x values. So they're saying that everything up to 2 will work. We're used to, you guys are conditioned to hearing inequalities where x is greater than or less than. So if you read it like that, it says 2 is greater than x. It's saying that 2 is bigger than all of the x values. So that's why it's everything below it. So I personally, when you get to this point, you should flip it. As soon as you see that x is on the right, just move everything. Just absolutely switch. When I switch x and 2, it's like it's on a swivel. You switch x and 2, and then the sign flips with it. Because that is confusing. I totally understand that. All right, let's look at this one. You guys get to this one, and you're like, oh, man. Everything was good until now, right? This is the same kind of problem, guys. What do we do? What do we do first? We just use our math skills to solve equations. 2 times 7 is 14x. 2 times negative 3 is negative 6. Less than 12x plus 16. Now, learn something from what we just did. Where do we like to have all of our x's? On the left. All right, even if it makes it negative, that's okay. Just move it to the left, and then if you divide by a negative, you flip the sign. But let's move our x's to the left-hand side. So I'm going to subtract 12x from both sides. Agreed? So 14 minus 12 is 2x. Minus 6 is less than 16. Should I move the 6 over? Okay, add 6 to both sides. 2x is less than, what's 16 plus 6? 22. And then do what? Divide both sides by 2. Did I multiply or divide by a negative number? Nope. So x is less than 11. So I need 0 on my number line. I need 11 on my number line. And what kind of a dot do I have at 11?
Shaded.
Closed. It includes it. And which way am I coloring? Everything to the left. I want all the values that are less than or equal to 11. So 0. Is 0 included in this solution set? Yes. So when I plug 0 into my original inequality, should it work? Yes, it should. So let's go back. You guys can do this mental math. Try to do this mental math. What's 7 times 0?
0.
Minus 3. Negative 3. Okay, so you have 2 times negative 3. Gives me negative 6 over here when I plug in 0. Now on the right-hand side, what is 12 times 0? Plus 16. Is negative 6 less than or equal to 16? Yes. So that means 0 is included, which is how we colored, so we're good. Take 2 little seconds to do that. I got another funny looking one. What does this mean when my x's are in the middle? We have to be fair to both sides. Whatever we do to isolate x, we have to do it to both sides. So I have a negative 4 here. I'm going to add 4, but I'm going to add 4 to both sides. So I have 9 is less than or equal to 3x, which is less than or equal to 18. Now what? Divide by 3. Am I dividing by a negative number? No. So 3 less than or equal to x, less than or equal to 6. Yes.
If one of them were negative, then would all of them change or just one of them?
Just the one.
Change? Okay.
What happens? Where are my dots? Where did the dots go? 3 and 6. What kind of dots do I have? Both of them are colored in, closed. And where am I coloring? In between. Good. I want all this stuff in between 3 and 6. So if I plug 0 in, should it work?
No.
No. Let's go back and look. If I plug 0 in right here, what's 3 times 0? So 5 less than or equal to negative 4 less than or equal to 14. Is that true? No, it's not true. So good. You guys did a good job.
And we know that it's not.
All right. Is this an in-betweener? Yes. So that means we have to be fair to the left-hand side and to the right-hand side. So the first thing I'm going to do is I'm going to add 4. So negative 8 plus 4 is negative 4. less than or equal to 5x less than 9. Now what? Divide everything by 5. Good. So negative 4/5 less than or equal to x less than or equal to 9/5. Not a big deal. But what do you guys notice about negative 4/5 and 9/5? One's negative and one's positive. Make sure, guys, I'm going to be checking that you have your spot, you have your reference, your numbers in the correct area. Negative 4/5 should not be on the right side of 0. 9/5 should not be on the left side of 0. You have to be careful with that. So now, what kind of dots do I have at negative 4/5 and 9/5? They're both closed. And where am I coloring? In between. Should 0 work? Yes. Let's go to the original. What's 5 times 0? Minus 4. So negative 8, is that less than or equal to negative 4, which is less than or equal to 5? Yep, that is true. Negative 4 is in between negative 8 and positive 5. Good. I have an in-between one, yes? Okay, so the first thing I'm going to do is to get x all by itself, I'm going to subtract 7 from everything. I'm going to subtract 7 from everything. So negative 3 minus 7 is negative 10, less than or equal to 3x. Can I say 1/2 minus 7?
No.
Some of you can, yes, in your head do this. But what should we convert 7 over 1 to? 14 over 2. Good, guys. It's a common denominator. So 1 minus 14 gives me negative 13 over 2. Now, this is important. You guys need to see this problem to understand. You've got to get this right when you're doing your computation. I need to get x all by itself now, so I divide everything by what?
3.
By 3. So I'm going to divide this by 3, and this by 3, and this by 3. So negative 10 over 3, less than or equal to x, less than or equal to negative 13 over 2 divided by 3 over 1.
Don't you multiply like the bottoms and then the tops?
We keep, change, division to multiplication, flip. 3 over 1 becomes 1 over 3. So this is negative 13 over 6.
So it's negative 13 over 2 times 1 over 3.
Yep, keep, change, flip. Am I going to do that to you? What? Divide fractions? Yes. Yes. One of the questions is going to be 1 plus 2 equals?
3.
Yes, there we go. Yes, sir.
Can't you just multiply this and then multiply that?
Mm-hmm.
It's fine.
Yes.
Why did you flip the 3 over 1 and not the 13 over 2?
Because the rule for dividing fractions is you keep the first fraction the same, you change the division to multiplication, and then you flip what you're dividing by. Keep, change, flip. Yep. Now, we get to this, and you guys are like, not really sure where that is on the number line. Okay, there's a couple ways you can do this. First of all, both of them are where compared to 0?
The left.
On the left, okay? Both of them are on the left. Now, somebody last period said, can I change them both so they have the same denominator? Absolutely. What would negative 10 over 3 become if I change it to sixths? Negative 20 over 6, good. And then I have negative 13 over 6. Okay, you can look at it that way. Or you can say to yourself, okay, how many times can 3 go into 10? 3. Right? So it's negative 3 and a bit. It's 1/3. How many times does 6 go into 13? 2. So it's negative 2 and a bit, which is 1/6. Which number is smaller?
Negative 2 over 1/6.
No.
Smaller?
Which number is smaller, guys? Look, this is negative 1. This is negative 2. This is negative 3. Which number is smaller? The negative 3 1/3. Negative numbers sometimes get us. So the negative 3 1/3 is here. The negative 2 1/6 is like here. And then where do we color? In between. Should 0 work? No, let's check it. Hold on one sec. Check it. What's 3 times 0? All right, check. So what's 3 times 0?
0.
And then 0 plus 7.
7.
So is negative 3 less than or equal to 7?
Yes.
Yes, that's true. But is 7 less than or equal to 1/2? No. So should 0 be on our solution? No, which it's not. So we're good. So this is the answer that I am looking to see. I need to see all of your work. I need to see your inequality statement, which is the negative 10/3 less than or equal to x less than or equal to negative 13/6. And I need to see your graph. When I'm looking at your graph, guys, I'm looking at your boundary points, which would be our negative 10/3 and our negative 13/6. I need to see where you shaded, if it's shaded correctly. And I need to see that the dots that you drew, whether they're colored in or they're open. All of that has to be correct. Sound good? Okay.